شغلنا ثاني. بسم الله الرحمن الرحيم. Okay. بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. Yes. Last thing I did. Yes. Good. All right. Fine. طيب بسم الله الرحمن الرحيم. Last time I talked very quickly about the matter. What's the meaning of matter?
Anything that
you have.
watch space and
I think can take a place and have.
Yes, and has a mass. Good. The matter consists of what?
Substance and mixture.
All right, the matter consists of substances. That's where we have the substance. Okay, so we have matter, and the matter consists of substance. This substance could be what? One element, we call it elements, or compound. All right? Or a compound. What's the difference between element and compound?
compound consists of two or more elements.
Element, what? Or more what? Different element. Right?
Element from same.
The compound is the combination of two or more elements.
Only two elements. Element could be single element. Give me example of single element.
O2, H2.
Helium.
Helium, single element. And give me an example of two elements.
Oxygen.
In acid.
H2O.
Flow.
Oxygen.
Or a compound, yes, H2O. Okay. Example of compounds like H2O. The handwriting is not good, but H2O. And this one is like potassium or sodium or things like that. Okay. Then we have mixture. What's the meaning of mixture? More than one substance together. Right?
Two substances or more.
Okay. This could be homogeneous or heterogeneous. What is the difference?
Homogeneous is difficult to separate it. Heterogeneous is easier.
No. Homogeneous, they are very well mixed together. Heterogeneous, they are not mixed with each other. It's not separation. It is just homogeneous means they are mixed together. Heterogeneous means not mixed together. Give me example of homogeneous.
Sugar with
Salt and water.
Salt and water.
Exactly. Salt and water. Exactly. Heterogeneous.
Salt.
Sand and water.
Sand, water, or iron and water. Okay. How can we separate mixtures? Using physical method. What do I mean by physical method?
Not in the lab.
boiling.
Like boil.
Boil or
Like evaporation.
This means you can do it at home. If I ask you to separate sugar from water, can you do it at home?
Yes. By
Yes.
boiling
Yes.
the water.
Take water, put it in the fire, it will boil and you will keep the sugar. Good? All right. How about substance? Again, a substance. Can we separate the compound, the elements from the compound?
No.
Yes, we can.
You can
but
by
chemical
chemical methods.
chemical methods. Chemical methods only. Clear? Very good.
Yes.
All right. Next, we're going to talk now about SI elements, or the mass, temperature, and volume and density. Very good. From now on, we are going to use these units. Very important. Whenever we talk about mass, these are called, and I want you to memorize this very well. What's this word? SI unit. I want you to memorize the word SI unit. SI stands for System International. You don't have to know these words. System International. I want you to know SI. Keep SI in your mind. Clear? Okay. What's this? Meter. When we want to measure distance, we're going to make what? To use what? Meter.
Meter.
If we have mass, what we are going to use?
Kilogram.
Gram, not gram, kilogram. Clear? If it's time.
Second.
If it's electric current.
Ampere.
If it's temperature.
Kelvin.
Kelvin. If it is, and this you don't know yet, or you know it from high school, amount, we're going to talk about mole. Mole. And the last one, candela. Since this is for light, not important. So you don't have to memorize it. I hope this is clear. Okay, good. Next, I want you also to know these letters here. What's this? Tera means 10 to the power 12. Giga means 10 to the power 9. Mega means 10 to the power 6. Kilo means 10 to the power 3. DC mean, you have to memorize these. Whatever I write in the underline with the red thing, you have to actually memorize them very well. Then DC is 10 to the power minus 1. Centi means 10 to the power minus 2. Milli means 10 to the power minus 3. Micro means 10 to the power minus 6. Nano, everybody knows nano now, 10 to the power minus 9. And then 1 pico means 10 to the power minus 12. What do I mean by this? If I tell you I have now 5 nanometer, how many meters is this? Quickly.
5
to the minus 9.
5 times 10 to the power minus 9 meter. I want you to know how to make this transfer. Clear? Now, if I have 6 meters and I want to change it to micro or picometers, how many picometers is this?
Minus 12. 10 to the power minus 12.
Now, listen to me carefully. I have 6 meters and I want to change it to picometer.
10 to the power 12.
Say 6 times 10 to the power plus 12 picometer. Is this clear? Why? I'm changing from meter to picometer. If I want to have, again, I repeat one more time, if I have, let's say I have 200 picometer. How many meters is this?
10 to the power 12.
200 times 10 to the power
Minus
what?
12.
Minus 12.
Minus 12 meter. Clear? Or equal to what? 2 times power 10 to the power what?
10.
10, minus 10.
Minus 10.
Meter. I hope this is clear. Can you make this transfer? I want you to memorize all these letters. memorize these prefixes. You must
دكتور
very well, and you must memorize the relation between them. Clear?
دكتور,
Yes.
why it's positive 12 6 meter you transfer to BM and you put it positive.
Always ask yourself, which is bigger, meter? All of these are bigger than a meter, and these are smaller than a meter.
Smaller.
So if you want to change from, if I have 5 kilometers, how many meters is this?
Sorry, what?
5 kilometer, how many meters?
5,000 meter.
5,000 feet.
I want you to put it in power. 5 times
10 to the power 3.
10 to the power plus 3, which is exactly like this, right? And meter. Now notice, kilometer and above, all of these are bigger than a meter. So we have to multiply it by 10 to plus power.
دكتور it's picometer.
Yes.
DC and below are less than meter. We have to multiply by power of minus, not power of plus, but power of minus. Is this clear?
دكتور it's picometer and you multiply by plus.
Yeah.
Yeah, because I'm changing from meter to picometer. If I want to change picometer to meter, I have to multiply by 10 to the power minus 12. Let me ask you this simple question. What's the distance from here to Riyadh?
400 kilometer.
400 kilometer. Now, if I want to have, I want to know this in meter. How many meters is this?
4,000.
400 times?
Oh, no.
Times 10 power 3.
3 to make it meter. Is this clear?
Yes.
Yes.
Now, if I have 6,000 meter, how many kilometers is this?
6 times 10 to the power minus
6 to the power minus 3.
Is this no plus
6
6, only 6.
only the power 0. 10 to the power
6,000 times 10 to 3. No, minus 3.
See, what did you do here? You multiply by 10 to the minus 3. When you change kilometer to meter, you multiply by 10 to the power minus 3. If you want to change meter to kilometer, you multiply by 10 to the power plus 3. Is this clear? I hope this is clear, and you have to memorize this very well. Good. Now, in temperature, we're going to use what unit? Kelvin. Kelvin. What's the symbol for Kelvin?
K.
Okay.
Everybody knows Kelvin. What's Kelvin equal to?
Minus
Temperature in Celsius.
Yes.
770.
Celsius.
Plus 273.
273.15.
50.
Memorize this number.
5.
Memorize this number. 273.15. Clear? Clear?
Yes,
I
great.
hope so. Okay.
Yes.
There is another unit. What's this
Yes,
unit
please.
called?
Celsius.
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 Celsius. What's this unit called?
Kelvin.
Kelvin. Kelvin and Celsius. Memorize it and memorize it very well. Next, is there another unit that we use for temperature?
Fahrenheit.
Yes.
Fahrenheit.
Fahrenheit degree. Look at the degree. When you put degree there, it makes it Fahrenheit. This F means Fahrenheit, and this is degree. Is there a relation between the Fahrenheit and degree, and the degree C?
Yes.
Yes.
Okay. Let me also ask you here. Let's go back to degree C. Degree C. What's the freezing for water for degree C?
0.
0.
0.
Boiling.
0.
100.
100. Exactly. Okay. So this is freezing and this is boiling. How about degree Fahrenheit? What's the freezing?
32.
32. You have to memorize this. 32. What's the boiling for Fahrenheit?
313.
180.
313.
No.
No, 212.
212. 212. You must memorize these numbers. This is the boiling for Fahrenheit. What's the difference between this one and this one?
Nothing.
Fahrenheit is much.
What? The difference between
100.
12.
180.
180. So in Fahrenheit, from freezing to boiling, there is 180 degree. Clear? Okay. In centigrade, from freezing to boiling, what's the difference?
100.
100.
100.
Okay. If we put 100 over 180,
5/9.
this will be 5/9. I want you also to memorize this number. Clear? Now, after that, I want you to, so we know this already. Very quickly, let's solve this question. Normal temperature for a person is 36 degrees C. That's your temperature. All right? Between 36 and 37. That's your body temperature. What's this in Kelvin? Very quickly. Kelvin equal to what?
300.
303.
I mean 36 plus what?
310.63. 270.
27.
3.15.
3.15 and you have them. Okay.
300 and 309.
9.15.
309 or 310. Clear? Very good. Now, I want you also to memorize this relation. You know now from where we got the 5/9, right? That's how
Yes.
you change from Celsius to Fahrenheit, from Fahrenheit to Celsius, or from Celsius to Fahrenheit. I want you to write these relations and memorize them. So degree C equal to what? Degree F minus 32, you put this in parentheses, multiplied by 5/9. Write this relation. That's if I want to change from a Fahrenheit to Celsius. How about if I have Celsius and I want to change to Fahrenheit, it's actually degree 9 over 5 times degree C only. The whole thing is plus 32. Is this clear? So in the first one, we subtract 32 from the Fahrenheit first, and then multiply by 5/9. But for degree Fahrenheit, if I want to change from centigrade to Fahrenheit, I first multiply by 9/5 and then add 32. I want you to memorize this relation extremely well. Write them, we'll solve a problem right now. Did you write them?
Yes.
Okay, good. Now solve this problem. The temperature 39, your body temperature, when you get 39, then you are sick. That's 39 in degrees C. How can I change it to Fahrenheit?
9/5 times C
I have to multiply
plus
first
32.
5 and then what?
Plus
Add
30.
plus 30. Do it very quickly and give me the answer.
102.2.
You have to bring, by the way, always bring a calculator with you. I want you to do the calculation in class. Always bring it with you. Okay.
90.6 Fahrenheit.
1 or what?
102.2.
Exactly. Good. You know it now. Okay. For volume, what we use for volume? What's the SI unit?
Cube.
What's the SI unit? For measurement. Measurement. What?
Meter cube.
Volume, we have, the volume is always, like for cube, we have to multiply what? Length by sides by height, and that's why it is meter cube. All right, and that's the meter. If this is the meter cube, this is the centimeter cube. All right, the centimeter cube is part of the meter. Now, if we have 1 meter, how many centimeter is 1 meter?
100.
100 centimeter. Everybody knows this, right?
Yes.
Okay, if I have 1 meter cube, which is the volume, how many centimeters is this?
100 for
300
times
1000.
10 over 3.
Times a centimeter. All of this is to the power 3. What's this equal to?
1 million
1 million
1 times 10 to the power 6, which is 1 million centimeter cube. Is this clear? Good. One more. If I have 1 meter, how many decimeters is this? Yes?
Minus 1. 10 to the power minus 1.
Minus 1. 1 meter is 10 decimeter. If I have 1 meter cube, how many decimeter is this?
1000.
It's 10 decimeter. All of this is to the power 3, which is 1000, or 10 to the power 3 decimeter cube, which is 1000. Is this clear? Good. We have another name for centimeter cube for volume. We have centimeter cube. The other name for it, we call it milliliter. Write this and memorize it. For decimeter cube, we have another name for it is liter. Everybody knows the liter. Do we use liter in our life?
Yes. Liquid.
Easy.
For liquid.
The bottle, right? Right? So if you go and buy milk, for example, you will buy 2 liters or 3 liter cans, right? You know the relation now. If you have 1 liter, this is how many meter cubed?
1.
1, 10 to the power what? So,
3.
ask you now, 1 meter cube, how many liters is this? How many liters?
10 to the power 0.
10 to the power what?
0.
No.
3.
1000 to the power 3.
Power 3. I told you that a liter is exactly 1 decimeter cube. That's why it's exactly like this. It's 10 to the power 3 minus 3, exactly. Is this clear? All right. And 1 meter cube. 1 meter cube. How many milliliter is this?
1
1
milliliter.
times 10 to the power minus 3.
Million milliliter. Is this clear? 1 million milliliter. I want you to memorize this relation. Memorize them also very well. Very well. Good. All right. Next. Everybody knows this. We have been talking about this a lot. What's this?
Density.
What's density?
Mass over volume.
Mass over volume.
Density means what? Mass over volume.
Mass over volume.
Okay. What is the unit that we're going to use for mass?
Kilogram.
Kilogram. SI unit. Yes.
I have a question about the last example.
Just a second. Let me finish this and we'll go back. The mass, we will use kilogram. For volume, if I want SI unit, what is it?
Meter cube.
Meter cube.
Cube.
Meter cube.
Meter cube. That's the volume in meter cube. Is this clear? Good. Now, I want you to memorize this. What's the density of water? What is the density of water? H2O.
1.000.
1, huh?
1. You have to memorize this. 1 what? What's the unit?
1, yes.
Gram over
Gram over meter cube. Centimeter. Centimeter cube.
gram over centimeter cube. Centimeter cube. All right? Can we make it now? I want you to make the density in kilogram over meter cube. Kilogram in meter cube. How can you do it?
1,000.
What?
1,000.
Okay, we'll change. What would be down? The gram, how can I change it to kilogram?
Divided by
1 multiply 10 power minus 3.
No. If I want to change it to kilogram, I multiply by 10 to the power plus 3. Is this clear?
Yes, yes.
Yes, Mr.
Why don't minus 3?
Oh, I want to multiply by minus 3 to change it to kilogram. Yes, yes, yes. So minus 3. What again? Yeah, to change it to kilogram, I will multiply by 10 to the power minus 3. Exactly. Is this clear?
Yes.
Yeah.
Good. And if I want to change centimeter cube into meter cube, I will multiply by what?
10 power minus 2.
10 to, this is cube.
Power 2.
6.
6.
10 to
Minus
the
six.
power, 10 to the power minus 6. Is this clear? And this will be equal to what in this case? 1,000
1,000 up.
gram, sorry,
Kilogram.
per meter cube.
Cube.
Is this clear? So the density of water is 1 gram per centimeter cube. The density of water is 1,000 kilogram per meter cube. All right. And of course, what's the other unit that I can use instead of centimeter cube? What? Hello?
عيد سؤالك دكتور معليش ما سمعت زين.
Centimeter cube. What's the other unit that I can use for it?
Liter. Liter.
Very good. What's your question about this one? Somebody said he wants this slide.
And the last example down. Why it's not 10 to the power 9?
Why?
Because we multiply put the two sides to the power 3.
100 to power 3, what is it? 10 to the power 6?
No, I mean down the liter.
Yeah, the liter. The liter. What's the liter? The milliliter.
He mean meter and millimeter.
Millimeter. Right?
Yes.
1 meter is equal to 10 to the power 2 centimeter. 1 meter cube is equal to what? 10 to the power 2 centimeter cube. 10 to the power 2 cube is 10 to the power 6 centimeter cube. Clear? And 10 to the power 6 centimeter cube, I can change it instead of centimeter cube, I can put milliliter. That's the relation between meter and centimeter. Is this clear?
Yeah. Yeah, clear.
Okay, good. All right. A cube floats in a glass of water because it has this. Of course, if you have a cup and you have water in it, and you add ice to it, where the ice stays? Up, right? Why? Why? Because
the density of ice is less than the density of water.
Okay, so what's the density of water?
1.
1. So what is the density of ice?
Less than 1.
Less than 1.
Okay, we have cube here. Cube. Each side of the cube has 2 centimeter, and the mass is 7.36. What's the density of the ice? Go ahead and calculate it.
0.9892.
Somebody said 0.9 what? 2?
Yes.
Okay, good. What did he do? You must divide it 7.36. Divide by what? This is each side is centimeter. So what's the volume?
Change for units.
2 cube.
2 times
Cube.
2 times 2, which is equal to what? 8 centimeter cube. That's the volume. And the mass is this one. So what did he do? He divided 7.36 divided by 8, and you have the answer. And this is the correct answer. Clear? All right?
Yes.
Good. All right. Okay. Physical properties and chemical properties. Did we see these words before? Where did we see physical property?
The mixture.
We mix things together, right? In mixture. We can separate them by what?
By physical properties.
Physical method.
Physical method, sorry, yes. I'm sorry. Physical property is related to, when we say physical property, things we can see, which means if it's gas or liquid or solid. And I want you to memorize this letter. What's this letter? Stands for what?
Gas.
This one?
Liquid.
This one?
Solid.
Solid.
Physical properties. Physical properties. Is this clear? Okay, let's go over things.
Yes.
Before we start, I want you to know these words. This is English now. I want you to write these two words, qualitative and quantitative. Quantitative and qualitative. What's the difference between them in spelling? Only one letter different, right? What's the difference here?
N.
The N and here?
L.
L. Quantitative and qualitative. Clear? Quantitative is related to numbers. Numbers. Qualitative means description. and I'll tell you example. Okay, what is the how many when you buy for example bottle of Pepsi can? Or anything. If you okay, no, let me if I ask you, for example, if we have a lot, I mean, like, let's say I have these circles, okay? 1, 2, 3, 4, 5, 6, 7. I have these circles. How many circles do I have?
7.
7. This quantitative or qualitative?
Quantitative.
Quantitative. What's the color of these balls?
Red.
Is it qualitative or quantitative?
Qualitative.
Is this clear? Okay. Okay. We already talked about physical property. What's the physical property means? It's either what?
Gas or liquid.
Gas, solid and liquid.
Exactly. Good. Physical change. What do you mean by physical change? Goes from solid
boiling, melting,
to liquid. Right? If you
From
go
liquid to solid.
from
melting,
solid to liquid, what do you call this process?
melting,
Melting. You have to know this. Melting. If you go from liquid to solid,
Freezing.
freezing or solidifying. They call it also solidifying. If you go from liquid to gas,
Boiling.
evaporation,
Evaporating.
Evaporating, exactly. From gas to liquid,
Condensing.
condensing, exactly. You have to know all these words as well. Good. Chemical property is if you have chemical reaction. Chemical reaction. Like, for example, if I take H2, what's H2?
water,
H2, it was
Hydrogen.
hydrogen,
If I react hydrogen gas with oxygen gas, what am I going to get?
water,
Water. After I finish the reaction, is there going to be any hydrogen available? Never. Clear? So
Yes.
chemical change is to have a chemical reaction like this. And chemical change, it will change the whole thing. I mean, the hydrogen will change completely to water. I hope this is also clear. Okay. We have also extensive properties and intensive property. Extensive means related to mass. Okay? And intensive means not related to mass. For example, if I have 1 kilogram of water here and I have 3 kilograms of water here. Okay? How much water do I have here? How much water do I have here?
1 kilogram.
1 kilogram. Is this extensive or intensive property?
Extensive.
Okay, how many kilograms of water do I have here?
3.
3 kilogram.
Is this extensive or intensive?
Extensive.
Extensive. What's the density of the water here?
1.
1.
1. What's the density of water here?
1.
1. 1. Clear?
Yes.
And what the density is intensive. So density is intensive property. The density of water is 1, regardless if you have 1 kilogram of water or you have 1,000 kilogram of water. The density is 1. Is this clear?
دكتور
What?
دكتور
I hope this is clear. I don't know if you are hearing.
دكتور
Yes, بسرعة.
So if it was the mass extensive property, I think the volume should be also right.
The volume is also extensive, Robert.
Extensive.
Yes. The volume is also extensive. Yes.
Thank you.
Density and temperature is intensive property. Temperature, if this is boiling water, what's the temperature here? If it's boiling.
100 to say.
100. Even though it's 3 kilogram. What's the temperature here if it's boiling?
Also,
Also 100. Clear? But
yes.
mass and volume is what?
Extensive.
Extensive. Depends on the
Property.
I hope this is clear. Mass and volume is extensive. Density and temperature is intensive. Clear? Good. Look at this example. If you are always at A, and I want to show, consider that this is a compound. If I want to go from A to B, only from A to B, is this chemical change or physical change?
Physical change.
Physical.
physical.
Look
كيميكال
carefully.
لأنه الأتومز
Chemical.
Or chemical.
It's not
تفرقت
Chemical. Chemical.
Why is it chemical?
It's not chemicals.
Mm.
Only
The compound change. It was green and red, then two greens now.
Red and green. Is this clear? So it is chemical change. Good. How about from A to C?
Physical.
No.
Physical.
No.
Chemical change also.
Chemical.
Chemical. Why?
They was combined and
Separated.
Now the green with the red were together. Now the green is alone and the red is alone. Clear?
Yes.
Good. How about from A to C or to D?
Physical.
Physical.
No change to the compound. It only changed its state. It become gas. Is this clear?
Yes.
Yes.
Oh, this is clear. Very good. All right. Next, very important subject. I want you to talk about these significant. We will talk about now significant figures. Significant figures. When you write any number from now on, if you write 2, 3, 7, 5, 4, then everything here is significant. If I ask you how many significant figures do you have in this number, you should say 1, 2, 3, 4, 5 significant figures. Clear? Clear? Very good. If there are number like this, always say 5 significant figures. If there are 0, be careful with the zeros. If the zeros is in between the number, for example, if I say, how many significant figures do I have in this figure?
6.
You should
Six.
go and count 1, 2, 3, 4, 5, and 6, and you should say 6 significant figures. Clear? So if the zeros in between numbers, then they are significant. Now, if the numbers are behind the number, like this one, then how many significant figures do you have in this case?
One.
One significant figure. The zeros to the left are not important. Clear? Okay. Significant figure. Now, I will stop here, and then I will, before I go this, I want to, we don't like to have numbers like this in science. We like to write the numbers like this in scientific notation. If we want to write 2, 3, 7, 5, 4, We don't like to write the number like this. We like to write it 2.3754 times 10 to the power, what? Help me.
4.
This is called the scientific notation, and this is the we write the numbers in what's called scientific method of writing numbers. Okay, and in this case, again, I will continue here. The same thing will apply here. If we have anything like, for example, I have this number only, which is 2.3754. How many significant figures is this?
5.
How many significant figures in here? If this is 1. 6. And if I put, for example, a decimal here, how many significant figures do you have here? Still 6. All right. How many significant figures is here? 1. Even if I put the 0 dot here, how many significant figures do you have here?
Still 1.
1.
Still 1. The zeros to the left, there is no numbers before them. They are not important. And we don't like to write the number like this.
Scientific notation. -4.
Doctor, we cannot hear you.
Okay. If there is all right, if there is this number, we say that how many significant figures is this one? If there is no decimal,
4.
if there is no decimal, we say it is ambiguous. I don't know. If there is no decimal, then the answer is I don't know. If there is a decimal, like for example, if I write 2, 0, 0, 0, and dot, then how many significant figures is this?
4.
This is exactly 4 significant figures. All right, but this one I say ambiguous, means I don't know. Ambiguous.
Can be 1 or 2 or 3 or 4.
It could be anything. Ambiguous, I don't know. Clear?
Only with zeros, right?
It could be 1 or 2, it could at least 1, but it could be also 4, but I don't know. I have to have the decimal. Very good. Very quickly, tell me how many significant figures in A?
3.
3.
Ambiguous.
How many significant figures in B?
4.
4. Yes. How many significant figures in C?
3.
3. Exactly. How many significant figures in D?
1.
1. No.
Ambiguous.
4.
Why 4? Because there is decimal. If there is decimal, then everything is decimal, as significant. So we have 1, 2, 3, 4. So it's 4 significant figures. Is this clear?
Yes.
Now,
No, doctor. How it's 4?
Because when you have decimal, like this one, all the zeros to the right are significant. So these are significant. So 1, 2, 3, 4. Clear?
Yes.
Okay. Now, if we have 50, how many significant figures is this?
Ambiguous.
Ambiguous.
Yes.
Could be what?
1 or 2.
2 or 1.
1 or 2. It could be 1 or 2. How about if I write it like this?
2.
2 significant. 2.
How about if I write it 5 times 10 to the power 1?
1.
How many significant figures do you have here?
1.
1.
What is 5 times 10 to the power 1 equal to?
1.
50.
50.
50. But how many significant figures we have here? Only
Just
one.
one.
Here we have 2. Is this
Doctor.
clear? So if there is a decimal, then we can tell. How many significant figures we have here? Last one.
4.
4.
4. 4. Why? Because this 0 is what?
There is 0 at the left, so we don't count it.
Not significant. Not significant. But the 0 is to the right.
It's significant.
Why this one is significant?
Because we have decimal.
Because we have decimal. Clear?
Doctor,
Yes.
and say it's not not significant, the one before the number.
Yeah, the one here actually is before the decimal is not significant.
No, and say example, there are 2 zeros.
How many is this? How many figures do you have here?
1.
1 significant. 1.
How about here? How many significant figures do you have here?
3.
3.
3. All these zeros are not significant. Clear? Okay. Now, when we have any number, what's the meaning of rounding? Rounding, if I want to make 102, 122.36. If I have this number, 122.36, how many significant figures is this one?
5.
5.
5.
I want to make this only 4 significant figures. How can I make it 4 significant figures?
122.4.
Point what?
4.
Why did you write 122.4?
We round 6.
Round.
Make it 4. Is this clear? That's called rounding off, and you have to know how to round off. Okay? Now, if you want to add numbers significantly, like this one, look at this example and look carefully. If you want to add numbers, whenever I give you add or subtract number, put the number under each other like this one, and like this one. Notice here, what did I do? I put the decimal exactly under the decimal, right? And then add them together like what we did here. Add them using your calculator and put the answer and put the decimal again under the decimal in here. Is this clear?
Yes, clear.
Yes.
Then, when you add them, go and count how many significant figures do we have after the decimal in here?
2.
2. And how many significant figures do we have in here?
3.
After the decimal?
3.
3. Your answer should have the one with the least, not with the one with the maximum, with the least. So, is this the correct answer?
No.
No. What's the correct answer?
7.
7, 3. Why is it 7, 3? Because I want it to be 2 significant figures similar to this one, not 3 similar to this one. Is this clear?
Yes.
Okay. This is when you do what? Adding or subtracting. Adding or subtracting. That's how you do significant figures, in adding or subtracting. Good. But if you have multiplication, okay, very good. Now we're going to subtract these numbers. You subtract them using your calculator, and that's the answer. Is this the right answer now, from significant point of view?
No.
How many significant figures do you have here?
2.
2. How many here?
1.
How many should we have here?
1.
Only 1. So how should we report this answer? 1, 2, 3, point
Two.
2.
We
Clear?
round it to 1.
Exactly. Round the 9 to 2. Is this clear? Very good.
Yes.
But if you have multiplication, I don't care about the decimal. How many significant figures do I have here?
2.
And how many do I have here?
4.
4. I will write at the top of them here 2, here 4. Clear? Your answer, this is your answer by your calculator. You multiply 1.4 times 8.011 and your answer is like this one from your calculator. Your answer should have the one with the least. Look here, I count all the figures, not like adding and subtracting. In adding and subtracting, how many, which numbers I counted for significant? Only
After the decimal.
After the
decimal. But in multiplication, I counted everything. Clear? And your answer should have only 2 significant figures. So how can I make this 2 significant figures?
11.
Only
11.22.
11. 11 only. So the answer is 1, 11. When I divide this number, how many significant figures do I have here?
4.
4. How many here?
5.
5. Your answer should have how many? This is from your calculator. But your answer should have how many significant figures?
4.
Only 4.
So is this significant? This 0, is it significant?
No.
How about this one?
No.
I said
From 3 to...
From 3.
2, 3, and 4. So I have 4, and this is the answer. 1, 2, 3, 4. Is this clear? That's how we do multiplication and division. All right? Okay. I will stop here. Let me just mention one thing. When we say exact number means it's not significant. It's exact. For example, what is the meaning of significant figures? Significant figures we use in measurement. So if I have this line from A to B, and let's assume that I want you to measure the distance from A to B. Well, how can you do it? You will bring a ruler and you will measure from here to here, and you will find that, for example, this one is 3.2 centimeter. Right? Maybe your friend is going to measure this distance. He will not find it 3.2. He will find it 3.1 centimeter. Is this possible? It is possible because it depends how you measure it. Okay? And maybe another friend will come and make the measurement and he'll make it 3 point what? 3. There is always error in the last number. And that's why when we write the numbers, we say that is 3.2 plus, sorry, 3.2 plus or minus 0.1. And this is the error in measurement. That's how many significant do I have here? How many significant figures I have here? 2. I am sure about this one. See, all the students wrote this 3, 3, 3. They did not change it, and they're sure about it. But this one, it depends on the student. It changed from one to the other. You are not sure about the last digit here. And the error, which is 0.1, is in the last digit only. Clear?
Clear.
That's why if I write 3.273, what's the error in this one?
0.001.
1.
The last digit.
In the last digit. How many significant figures do we have here? 4. This is exact.
4.
Exact. This is exact. And this is not exact.
Not exact.
But if I ask you, how many fingers do you have in your hand?
5.
5. Can you say it is 5.1?
No.
No. So when we say exact number, if we have things like exact, so we said 5 fingers. Nobody can talk about 5 fingers. If we have 3 eggs, 3 eggs, okay?
Yes.
How many eggs do we have?
3.
3. Can we have 3.1 egg?
No.
No, it's 3 eggs. And each egg is mass is 2.5 gram. Then what's the total mass of the eggs?
7.5.
2.5, exactly. How should I report it? 1 or 3 or 2 significant figures? In exact numbers, don't count them in significant figures. So I don't care how many significant figures here. It's exact number. No need. There is no error in this one. The error is only in mass, which is 2.5, and that's why when I report it as 7.5. And with this, I will stop the lecture. I'm already slightly late, and we'll continue the lecture next time, inshallah. All right, so we have